morning, everyone. How many students is here? I just saw got 9 is waiting here. Hello, good morning. Long time we never live already. So today I want to go through to the lesson 7. This one is the last topic for your chapter 5. Okay, good morning, Yiru. Good morning, Ho. Okay, so can listen me or not? Okay, you just reply me. You can listen me or not. Okay, Cole, Angel, Cole. Good morning. Okay, can listen? Can listen what I'm talking about? Okay, Jessica Hall. Okay, so that means I can continue my lesson. Okay, Mei morning. Okay, so this one 7.1 actually along a bit lah. I go to separate by 2 parts. So the first part about the theory. Okay, the second part about the calculations. So the first part I cut it become short a bit. The following the 7.1 part 2 should be longer a bit because about the calculations. So we go through about quantum theory. This one is a new topic for this KSSM, the new syllabus. Okay, let's see what is a quantum theory. Okay, first one to show you is a spectrum. Okay, I think this one you learned before during the form 4 about the wave spectrum. Okay, EM spectrum. So you need to memorize the arrangement. So from here we go through to see, okay, how they go to arrange the positions for the different of the ray in the spectrum. They follow by the wavelength and also the frequency. So you can see from the radio wave, the wavelength is longer. Okay, the wavelength is longer and also the frequency is lower. Okay, after that, the frequency is keep increasing from the left, go to the right. Okay, from the left, they go to the right, they keep increasing. So from here means until gamma ray, the frequency should be the highest. Then you'll find the wavelength from the gamma ray must be very, very short. Okay, because the lambda and also the frequency, that's inversely proportional. So from here, we're going to see the center. We only can see there's a visible light. Okay, the visible light is between the infrared and also the ultraviolet. So that's why they're starting by the red color, then end by the violet color. So they're at the middle. So this one we call it as a visible light. Okay, so that means quantum, we need to learn about this part lah, about the spectrum. Okay, let's see what is that. Okay, electromagnetic spectrum, there's a continuous spectrum. You can see there's a continuous. Okay, after that, the spectrum consists of the 7 type of the wave with the different frequencies and also the wavelength. So this one, what's the differences for the spectrum? You must know that from the wavelength and also the frequency, there's an arrangement follow these 2 things. Okay, and wavelength as a frequency must be inversely proportional. Okay, now we go through and see the visible light part. Okay, visible light, that from the wavelength, longest one is a red color, 750 nanometer until to the 400 nanometer. So that means longest becomes shorter. Okay, visible light consists 7 color. Okay, the 7 color, they follow the rainbow color. So from here, the red light has the lowest frequency. Then the purple light, that means the violet, has the highest of the frequency. Okay, now this one is a function for different part, X-ray, gamma ray, then you know where they use it already, is it? So from here, all the object that will emit electromagnetic radiation. Okay, from the spectrum, all the wave here, okay, you can say microwave, you can say radio, infrared, they also can be emit electromagnetic radiation. So cool object, okay, emit the wave with the low frequency. Example, radio and micro. Radio and micro is a long wavelength. Then you'll find it, the frequency becomes smaller, is it? So this one is normally for the cool object. Okay, they represent by the cool object wave. After that, they produce the wave also become longest, and also the frequency becomes smaller. Okay, how about the hot object? Okay, the hot object from here must be the high frequency. Hot object here, they say ultraviolet, after that X-ray, and also gamma. This one should be the hot object emit the wave. Okay, with the higher frequency. So from here, example, they give you as visible light and also the ultraviolet. So this one, they will produce the hot wave. Okay, and the bottom one, they produce to the wave to produce should be the cool wave. Okay, so that means temperature also related about the spectrum. So you find the frequency becomes shortest, that one should be the hot object. Okay, then at the bottom one, you find it the frequency become smallest one. Frequency becomes smallest, then you find it that one, it should be the cool object. They produce the wave lah. Okay, so from here we continue. Okay, black body. Okay, what's a black body? Okay, so from here, there's a one of the idealist body that able to, okay, what they do it. Okay, you see the diagram, what they do it. They keep reflection inside the body, is it? So from here, first one, they must be explained. They absorb the EM radiation. Just now, the gamma ray, or they produce the radio electromagnetic wave, is it? So that means the black body, they will absorb. So from here, the diagram you can see, this one is a EM wave, radiation of the EM. They absorb by the black body. So after absorb, what happened? They will emit, they will produce the thermal radiation depending on the temperature. So that means after absorb the EM, they will release the thermal, the heat radiation. Then after that, release how many? We depend for your temperature. They absorb how many temperature? Then after that, they release different quality, not quality, different quantity of the thermal radiation. So that means when they just release out, we represent by using the color. Okay, so that means from here, when the black body, they will absorb all the radiation from the EM, electromagnetic. After absorb, they will release, okay, emitted the thermal radiation. So this one, thermal radiation, they want to emit how many? They must depend from the temperature they absorb is how many. So that means the temperature is depend from just now lah. That means the low temperature, the cool object, and also the high temperature, the hot object. Just now the radio wave and also the gamma ray. So this one is depend the temperature. After that, they release how many. So from here, they show you they release. Okay, this one is a white light. Okay, white light from there, the EM just now they go to absorb. After that, depends the different temperature. Then they produce out the thermal radiation is how many. So from here, you can see the different diagram. We're going to guess what is the temperature they absorb, how many thermal they produce. Okay, let's see here. Okay, you can see the diagram here. Okay, the thermal radiation, there's a EM, electromagnetic radiation, that including the visible light and also the radiation that cannot be seen by the human eye, such as the infrared. Not only for visible light, they also can involve infrared. Okay, you can see the color from here. Okay, red color, after that yellow, then you can see blue, is it? So from here, this one is the radiation that absorb. After that, EM absorb, then they produce the radiation for the thermal. So this one is what they produce out. Okay, what they produce out. So you can see different color, different temperature. So from here we find it, they release the thermal radiation, red color should be the highest temperature. Okay, so you can see the heart, inside the heart, they find it, there's a red color. So after that, the red color, they close with the yellow color. So that means the red and yellow almost a high temperature. So they can show the part. Which part should be the highest thermal radiation they produce. So the red color should be the highest lah. So they focus to the head and focus to the heart. So this one is what we can get the information after the radiation come out from the black body. Then they're refracted. Then we see what is the result. So another info you can see from here, the ray light that enter the ear cavity. This one also is one of the example of the black body. So black body just a one simple hole. Then the hole inside is all black color, no color one. After that, when the light just go, they just refracted. Okay, when the light just enter, they will absorb. Okay, absorb, after that inside they will refracted. After that they produce the thermal radiation, just like this only. So from here they say the ray light that enter the ear cavity, they will undergo repeat refractions. Is it your ear is nothing? Is it only the wall, inner wall only? So they will keep refracting inside the inner wall of the ear cavity. So at the ear, at the each refractions, the part of the ray are absorbed by the inner wall. Is it? Just now the black body also absorbed because the ray just go in, they will absorb it. So from here is the same. For the ear cavity, that means when the light just enter, they will absorbed by the inner wall of the ear. Until all the ray are absorbed, then the ear cavity act like the black body. So they just want to absorb all the light come in. So this one we call it as a black body. Okay, so from here we continue to see the result after they absorb the thermal radiation. Okay, so this one they want to show you the light intensity. Okay, and also the wavelength. So from here, first one you see the graph. Radiation intensity. Okay, y-axis against the wavelength. So wavelength is the x-axis. Now you got three types of the black body. Okay, three types of the black body for different temperature. Okay, let's see the first black body. Okay, 4,000 Kelvin. That's a red star. Okay, this one, the wavelength decreases. When the wavelength decreases, mean the frequency increase lah. Okay, frequency increase until the highest. You can see the top. The top highest for the intensity, there's a red color. So that means this one's a red star. So the maximum intensity sure is a red color lah, because they want to show about the red color star. So the maximum intensity they can show the color sure is a red color. So until the red color, this one should be the maximum. Okay, so we can say intensity increase, then the wavelength will be decreases. How about the frequency? Frequency increase. Okay, then after that, they go to drop. Okay, the intensity after that become drop. Okay, they never continue go to increase. Okay, this one is about this topic, quantum. We need to explain why they do not continue to be up. Okay, excuse me. So they still continue until red. Okay, they start to drop. Okay, start to drop. So how about the second one? Second one, we call it as a white star. Okay, just like the sun, white star. So this one is also same. When starting, the wavelength is the longest. So when it just keep the wavelength becomes shorter and shorter, means the frequency become higher and higher until maximum. That means almost is yellow and also the green a bit. Then become maximum the intensity. Okay, now the temperature is the highest. The highest. So until this part become maximum, after that they drop again. Okay, then they continue by the blue star. Blue star means blue color. Okay, so from here they go up until the maximum. That means they go to find the blue color light intensity. Until there, then they stop. Okay, then they keep dropping. So we can say the left-hand side. You can see the left-hand side. This one is all is a high frequency. All is a high frequency. Okay, so from here they're just using the graph to show you when the frequency just increasing. Okay, frequency keep increasing, the high intensity also will be increased. Okay, high intensity increase means they go to absorb. Okay, they go to absorb. Then after that, they will release. They will release the thermal radiations. Okay, so from here, we can see temperature keep increasing. The radiation intensity also keep increasing. Okay, So now we continue to the next part. As the temperature of the object rises, so that means 4,000 K, 5,000 K, 7,000 K, the object acts as a black body radiator, okay, and emit the thermal radiation at all the wavelength. So they don't care what wavelength. When the color just keep increasing for the temperature, then they will provide the thermal radiation. Okay, the thermal radiation produced is how many? So this one need to depends the color. Okay, the color. So we just know the radiation intensity. You follow the rainbow color. The violet, the last one. The violet, sure the radiation intensity is the highest. Okay, it's the highest. After that, they emit the thermal radiation is terbalik. Okay, they emit the radiation to produce out. There's a terbalik. So that means the red color they produce out should be the high temperature. Okay, the absorpted is a different. You see the absorpted is a 4,000 K only. Then this one's a 7,000 K. Then later you see the diagram. They react the thermal radiation for the diagram. The red color show there's a high temperature. Okay, means you are low temperature to come in, but I release the high temperature to become the wavelength. Okay, now we go see the diagram. Okay, wait. We still continue for this graph. So this one's a set. You can say white star. You can say the yellow star. Like almost the color is a yellow and also the white. So example, the higher the light intensity of the black body, the more light energy emitted. So that means the blue star sure more light energy to produce. Okay, light energy to produce. So every curved graph of the black body spectrum is a narrow at the left. Important you want to see is the left hand side. The right hand side, everyone is the same. The left hand side. The left hand side will become narrow and narrow. So which one become curved is more increasing gradient. Should be the blue star because there's the highest, after that they drop. Okay, which an area with the short wavelength and high frequency. So you must remember this part, the left hand side, this part, the wavelength is the shortest one. Then after that, the frequency is the highest. Okay, so we can make a conclusion actually. The frequency increasing, then the light intensity also increasing, or you can say the light energy also will be increasing. So from here, with the increasing temperature, so that means 7,000 K lah, the wavelength approaching maximum radiation intensity will also get shorter. Okay, so wavelength becomes shorter, then you find the temperature is the highest, then you find the light intensity also is the highest. Okay, so this part, important we need to focus is the left hand side, this part. Wavelength drop, frequency high, light intensity also high. Okay, who will achieve high light intensity? Sure is the star with the temperature highest. Okay, this one is what they go to absorpted. Okay, so you can see this one is an example, black body, daily life. So you can say, blue color should be the highest intensity, is it? Why they show the bonnet, the in front bonnet of the car is a red color? So this one is a release. Just now is absorb. They go to choose all the radiation, they go to absorb, is it? After absorb, they will release, they will emit the thermal radiation, remember? So when they just emit the thermal radiation, they follow the color temperature. So from here, when they just release the thermal radiation, they find it the red color should be a high temperature. Just now is black body go to absorb. After that, they want to emit the thermal radiation. So from here, the thermal radiation, when they just emit, the red color is a high temperature. Then follow, you see the blue color at the bottom, only 6 degrees Celsius. So from here, you can see this one diagram. This one diagram recorded at the thermographic image of the car. So from here, you can find it. The tire, maybe you after the long journey, they become hot, is it? So it become red color. So the body also a little bit high temperature. So they put it as a yellow color. Then after that, the red color, when it just emit out, sure is the highest temperature. Okay, so you must remember the black body absorbed and the black body emitted. Okay, the color, what they represent. Okay, after that, the oven. The oven also is a heating element. Then after that, we got thermal radiation in the light bulb at different of the temperature. You can observe above the filament. The filament is a different temperature. They find it the thermal radiation is a difference. So when you heat something, you can find the color keep changes, is it? So that one means the thermal radiation they go to produce. Okay, so this one is one of the example to let you introduction about what is a black body. Okay, and also you must remember just now the graph I show you. Okay, remember the left hand side. The left hand side become more narrow. Okay, means what? The intensity keep increasing, frequency is keep increasing. Okay, and also who will show you the maximum light intensity? There's a blue color, is it? The blue color is the highest of the temperature. Okay, so now we go through to the next part. Okay, again, the just now, red star, white star, suppose it's white star lah. We never mentioned about the yellow star. We mentioned as a white star. Then this one's a blue star. So you can see this one's a radiation intensity. So this one should be the wavelength. So from here, got diagram to show you red star. This one is an example for the red star. The star got different color. When you observe to the sky, you can see sometimes it's a white star. You can see got blue star and also the red star. So from here, you can see about the red star. The higher the temperature, the graph is a narrow on its left. So important, they want to mention is a left-hand side, narrow. The peak is at the red zone. This one's a red star. So the maximum light intensity sure is a red color. So you can see the peak, maximum peak is at the red zone. So the curve means is also emit the yellow light. So from here, the red and yellow almost closer. They also will be emit the yellow light, but most must be red color. Okay, so this one's the first star. They show you the black body. They show the red color. Okay, number 2 is a white star. White star, the temperature around 5,270 Kelvin. So from here, the hotter, the narrow of the left-hand side, still the left-hand side. Okay, hotter at the left-hand side, and also frequency must be the highest. We can see the white color, but they got combination about the green, yellow. They act as a white light. Okay, because they got combination. So you can see the maximum here. Okay, at the top here, the peak, you can see the mixtures with the yellow and also the green. So from here, they're straightforward to mention they're just like the white star. So this one, what you see about the white star lah. Okay, the surrounded got a little bit yellow, a little bit green. After that, center is a white color. Okay, and the last one is a blue star. A blue star you need to achieve must be 7,000 Kelvin. So this one is a blue star. It's the highest of the radiation intensity. And the frequency must be the highest lah. So we seldom to see there's a blue star. Okay, so this 3 is an example for the black body for different of the color absorbed. Okay, now we need to differentiate 2 parts. Just now I told you why until peak they will drop. Okay, now I show you another one. Another one graph. This one we call it the Rayleigh-Jean law. Okay, another scientist they go to create one of the graph. This one is a Planck. This one is a Rayleigh-Jean. So this one they find it the graph keep increasing. They never drop. They say the light intensity will keep increasing one. Okay, follow the Planck formula. They find it until the peak, they will drop. Okay, this one is a 2 of the different theory. So from here, this topic, they want to find out why the Rayleigh-Jean theory cannot explain for the quantum. Only the Planck, they can explain about the quantum, about the black body. Okay, so from here, we're going to see what is a classical theory. Classical theory, yeah. So from here, they say classical theory, they cannot be used to explain about the black body radiator. Okay, you cannot say about the black body when it just absorb and release the thing. Okay, but Planck, they can be explained. So we go and go through the detail. Okay, first one, example for the classical theory in the physics, the example light, wave, and also force. This one also can say about the classical theory. So light is a electromagnetic wave. Okay, that's a product from the vibration of the electric charge. Okay, a hot object, electron vibrate rapidly and also randomly in any direction and produce the light. Okay, as the object become hotter, the vibration of the electron become more energetic and more light will be emitted. So this one what we learned before lah, the light and also the electron. Okay, the electron in a hot object, they will vibrate in continuous frequency. Agree or not? This one is a classical what we learned before. So that means when the electron you keep increasing about the heat, they will vibrate, keep increasing, is it? So they say the electron in a hot object, they will vibrate in continuous frequency. So that means the frequency will keep increasing and increasing and increasing. Okay, so this one what we learned before. This one is a normal concept, is it? So when the temperature is just high, that means the object must be randomly to be moving. Okay, then we continue again. According to the classical theory, okay, we're talking about classical, the green color light, the electron vibrating at the same frequency should have the same energy content. Agree or not? Okay, so that means when there's a frequency is higher, that means your energy should be continue to be increasing lah, is it? Okay, the vibration of the frequency of the electron also has no limit, is it? If your temperature keep increasing, that means the frequency also keep increasing. There's a no limited. They will continue to be increased for the light intensity. Yes or no? This one is what we learned. That's a classical theory. Thus, the light energy produced by the vibration of the electron can reach unlimited high value. So that means you see the green light, the green graph, they keep increasing until the end. So that means when you just make the temperature increasing, that means the frequency of the vibration of the electron, they will continue to be increased. Then after that, they increase until the unlimited. Okay, unlimited light intensity. So this one is what classical theory they mentioned. Okay, but from here, follow for the Planck. They want to explain the black body. They find it, they never continue to increase the light intensity. Because until the certain peak, they will drop. Okay, the light intensity will drop. Okay, when the frequency is very, very high. Okay, you follow the classical, you find it. When the frequency is very, very high, light intensity continue to be increases. So this one is a differences for the classical theory and also the modern theory. Okay, so this one is a classical theory. We're talking about the light intensity will continue increase. Okay, when the temperature increase and also when the frequency increase. So you can see here, this one is a Rayleigh law. This one is a Planck radiation formula. Okay, so one more, ultraviolet catatrophy. You see what is a ultraviolet catatrophy? Okay, now we're going to explain this part. Modern physics, Planck. Planck is talking about the modern physics. Okay, the Rayleigh theory and also the Wien theory, they explain about the classical theory. Okay, the classical theory means they continue to be increasing the frequency. Okay, now we go through experiment. This one is the experiment part. They go to test which one the concept should be correct. So experimental, the result they're involving the black body radiation are inconsistent with the classical physics theory. They go to check the black body. Is it the modern physics is correct or the classical theory is correct? So now we go to find out. Based on the graph radiation intensity against the wavelength for the black body. Okay, the light intensity of the left side, this one left side, of the peak does not continue to increase. You see, this one experiment part, they find it. There's a not continue to be increasing for the light intensity. Okay, to increase with the increase of the wave frequency as the predicted by the classical theory. Okay, classical theory, they say when the frequency keep increasing, light intensity must be increasing. Okay, this one is a classical theory by the religions. Okay, but when do the experiment, they find it for the black body, when the frequency keep increasing maximum, but the light intensity will drop. Okay, will drop. So this one already is crash, is it? The theory already crashed for the modern and also the classical. Okay, when they do the experiment, they want to prove. Okay, so this one we call it, this controversy is the concept of the light energy has sparked the theory of the quantum physics. So because of the crashing, so that's why they create another theory. So this one theory called quantum physics. Okay, so because of this part lah, because of this one crashing, the concept is a crashing. So after that, they find out one of the experiment to prove it. So this one is a one of the concept about the light energy. There's a theory of the quantum physics. So today what we learn is a quantum physics. So we need to learn about this part, the graph that will narrow at the left hand side and the intensity will drop when the frequency increasing. Okay. Okay, so from here, what means of the ultraviolet catatrophy? So this one is a classical. This one is an experiment. So what is the ultraviolet catatrophy? The meaning is got differences, pecanggahan. That means the theory got, and also the experiment, they find out the result not the exactly. So this one is a one of the ultraviolet catatrophy. So from here, we go to explain for you what's the ultraviolet catatrophy. The ultraviolet catatrophy and the classical theory did not match. Okay, did not match the experimental data. Okay, so this one at long wavelength. Long wavelength is where this part. Okay, match is okay. Okay, long wavelength is okay. So this one we never say there's an ultraviolet catatrophy. No, this one is a match. Until this part. So this one we call it as an ultraviolet catatrophy because there's not match. Okay, so at the short wavelength this part, classical theory predict infinity energy. Okay, at the short wavelength, experiment show what? Show no energy. So this part we call it as a ultraviolet catatrophy because both is not matched. Okay, so ultraviolet catatrophy actually is one of the concept they're talking about the left hand side. When two of the theory is not matched, so we call it, this one is a ultraviolet catatrophy. Okay, for the right hand side is okay because both also is the same, keep increasing. So from here, the conclusion, this contradiction, we call it as an ultraviolet catatrophy. So ultraviolet catatrophy just only happen at the left-hand side. Okay, when they go to the highest part. So this one we call ultraviolet catatrophy. Just only the name lah. When I just ask you what meaning of ultraviolet catatrophy, then you need to explain about the classical, when the wavelength shortest, and about the experimental, the data, when the wavelength becomes shortest, both is not matching. Okay, for the classical, they keep infinity to increase. For the data one, they will dropping. The energy will drop until zero. Okay, so this one is the differences for the classical and also the Planck. Experiment actually is a Planck lah. They go to prove these two should be different concept to explain the black body. So conclusion is classical theory cannot explain about the black body. Only the Planck, okay, Planck theory, they can explain about the black body. So this one, Planck black body part, we call it as a quantum physics. Okay, quantum physics. Okay, idea that sparked the quantum physics theory. Okay, first one, we go and see the classical theory. Classical theory failed to explain about the quantum. Okay, now we go and see why they fail, why they cannot explain about the quantum. Okay, we got four classical theory from here. Okay, first one is a particle nature of the light. Number two is a double slit experiment. I think you remember the double slit of the experiment. Yeah, the interference, the diffraction, that one is a double slit experiment. Okay, after that, atomic theory from the Delton. And the last one is discovery of the electron. Okay, so these four is a classical theory. We're going to see these four, the classical theory is about what, and also the scientists, okay, what they go to create and what they cannot be explained. Not every result they can explain, is it? Some result we cannot explain. If the some result cannot explain, so that means they're crashing already. So another scientist, they need to do the experiment to prove it, is it correct or not? Okay, so from here, the first one, we go to find out Isaac Newton. Okay, Isaac Newton is talking about the particle nature of the light. So from here, Isaac Newton, 1643 until 1727. Okay, they describe about the light. Okay, they're talking about the light as a single stream of the particle of the corpuscle in 1904. Okay, they're talking the light is a particle. But there's an unsuccessful in explaining the phenomena of the light refraction due to the failure in comparing the speed of the light in the glass and also in the air. So they cannot prove about in the different medium how the light to travel. They not yet go to find out the result. Okay, follow the Isaac Newton. They only to say about the light is a particle only. So you can see the diagram here. Light is a one of the particle. Okay, but they cannot be proved. Is it the refraction for the speed in the air and in the glass? What differences? So this one is a one of the classical theory. Okay, then we continue to the second classical theory, double slit experiment. That means they're talking about wave. Okay, conduct the double slit of the experiment on the light in 1801 and show that the light is a wave. They can show the light also is a wave, but they're unable to explain the radiation spectrum produced by the black body. Okay, the black body also is a light, is it? But they cannot be explained. Okay, they only can say about the light is a wave. They cannot explain about the double slit, single slit. They cannot be explained. Okay, so this one is a one of the classical problem lah. The Thomas Young, they cannot be explained. Okay, after that is a Dalton atomic model. So this one you learn about the atom for the John Dalton, 1766 until 1844. Okay, so this one is a metal consists of the basic particle that cannot be further divided. We call atom. Okay, the smallest particle they call atom. Same element have the same type of the atom. Okay, element is the same one. For the atom, same atom, the element must be the same. But they're unable to explain about the light spectrum. This one is a light spectrum produced by the atom. They cannot explain. Or inside the light spectrum actually can produce an atom or not. They cannot be explained. Okay, they only can say the matter is an atom only. So this one is a Dalton atomic model. Okay, and the fourth one. The fourth one is a J.J. Thomson. Their discovery for the electron. Okay, remember your electron? Okay, they only say electron. They never say about the proton. So from here, they're talking about discovery the negative charge. Okay, the negative charge subatomic particle, they call it as an electron. So they designed the experiment to study about the behavior of the electron. That means they find about the characteristic for the electron, but they're unable to explain the line spectrum of the light produced by the electron. Still the same. They cannot find about the spectrum. Okay, cannot explain the line for the spectrum of the light produced by the atom. Same like the just now. Okay, just now the Dalton also cannot explain about the spectrum that can produce the atom. Okay, so this one is a what classical theory problem, what they face. So what you need to remember, the Newton Isaac. Okay, they find what particle, then you need to find out they cannot prove what, they unsuccess to prove what. Okay, number two, okay, we recall back. Number two is a double slit. Okay, they say about the particle, there's light also is a wave. The light also is a wave, but they cannot explain about the spectrum from the black body. Okay, so they got something to be unsuccessful to be explained something. I can say this one is a particle, but I cannot explain. Okay, how the refraction we cannot explain. Okay, I can say this one is a wave, but I cannot explain. Okay, about the radiation spectrum they produced by the black body. Okay, and the next one is a Dalton. They're talking about the atom. The matter also is an atom. Okay, every same atom, the inside the element must be the same, but they cannot explain about the spectrum also produced by the atom. Okay, and the last one almost same like the concept of the Dalton. They say about the electron. J.J. Thomson, they say about electron. Electron also is one of the subparticle. Okay, they find out the characteristic of the electron, but they still cannot find out the light spectrum also produced by the atom. Okay, so this one is a what they unsuccessive in the classical theory. So from here, the classical theory we cannot bring together with the quantum physics. Okay, so this one is a first introduction for the classical theory. Okay, so the next lesson should be go to the modern physics. That should be the quantum physics. So from here, just let you to know why this one classical they cannot explain. Okay, because they do the experiment, they unsuccessful. Okay, and also the Rayleigh jeans, they show about the wavelength, the frequency increasing, the light intensity also keep increasing. They cannot prove together with the experiment data. Okay, so from here, this one, the data, they should be find out from another scientist to explain about why they will keep dropping when the frequency increasing lah. So they bring out the black body to explain these situations. Okay, so from here, talk too much already. So no calculation, only the concept. So remember the scientists need, they find out, then what they unable to find out. So this one is a part one only. Okay, just introduction for you to know what is the starting about the quantum physics. Okay, so today the lesson only short. So what you need to do is you need to help me to do the Google form as your today attendance. The Google form got one of the code. Okay, remind you to write here. Okay, anybody typing faster, you help me to type the code for today lesson. There should be hashtag, then quantum. Okay, quantum, how to spelling? Quantum, capital letter. So you put hashtag, then you write quantum. Okay, Yiru, can you help me to type there? Okay, Yiru, can you help me to type in the chat room? Let every student can see it. Okay, you put a hashtag. Okay, so anybody help? You put the hashtag, then you write the capital letter of the quantum. Okay. Yeah, correct. Okay, thank you, Yiru. Okay, so from here, this one should be today the lesson code. Okay, inside got some of the objective question about what I'm talking just now, about the scientist name and what they create, and find out the graph also. This one is later the question. Okay, so the student, thank you for your attendance. So please do the Google form as today your attendance. Excuse me. Okay, thank you everyone to enter the class. Okay, please finish your Google form and submit. Okay, thank you everyone, and thank you for your joining today. Okay, everyone, bye. Thank you, Yiru. Okay, thank you.